looking at inequalities and how to solve and how to graph inequalities. What we're going to do when we're graphing them is you're going to have a number line. Always put 0 in the number line. Can't forget about me. I got to be on there. And put the number that you have here, 4, on your number line. We want x is less than 4. Remember, if it's less than or greater than, doesn't matter, it's an open circle. In this one right here, when you have the equal sign, like in the second one we'll do, that one needs to have a closed circle. And then with this, it's everything less than 4, so we shade to the left. The next one, x is bigger than 2, so there's 0, there's 2. It's greater than or equal to, so this time we have a closed circle, and I'm shading to the right because it's greater than. Now, for this last one, this one's a little bit trickier because x is in the wrong order. Let's flip it around. X and 5, put them in the opposite order. The arrow is pointing at the x, so when I flip it around, I got to flip the sign to keep the arrow pointing at the x. Now I have a much easier inequality to work with. There's my 0, there's my 5. I'm going to be shading to the left and with an open circle. And then here's the other thing too. If you have x on your left, it's really easy. The shading follows the arrow. So if it's pointing left, your shading goes left. If it's pointing right, shading goes right. Keeps it very simple. Now, for actually solving inequalities, just like solving an equation, subtract 5 here from both sides. X is less than or equal to 4. So then you would draw your number line, 0 and 4. This would be a closed circle, shading to the left because of the less than or equal to. This one, add 1 to both sides first. You get now 4x is bigger than 8. Divide both sides by 4. X is bigger than 2. So there's 0, there's 2. I want everything bigger than it, and it's an open circle in that case. Okay, look at a couple more. With fractions, excuse me, with fractions what you have to do is, what I would say, is just take the whole thing, multiply it by the denominator, multiply it by 3. So 3 times x is 3x. 3 times 2 divided by 3. Well, the 3's are canceling each other out. It leaves you just negative 2. Or if you look, 3 times 2 is 6. 6 divided by 3 is 2. It's bigger than 3 times 1 is 3. Divided by 3 is just 1. Now you have an easy one to solve. Add 2 to both sides. Gives you 3x is bigger than 3. Divide by 3, so x is greater than 1. So there's 0, there's 1. And I want open circle shading to the right. In this one, start by adding 4 to both sides. Get negative 3x is less than or equal to 12. Divide both sides by negative 3, and you will get x and negative 4. When you divide by a negative, here's the rule. You got to flip the sign. Only when you divide by a negative. It's not because I got a negative for an answer. It's because I divided by a negative number. So your number line, negative 4 with 0. And I'm shading with a closed circle off to the right. All right, here's another example. If I subtract 9 from both sides first, negative 6 less than or equal to 2x. Divide both sides by 2. Negative 3 is less than or equal to x. Okay, this is a case right here where a lot of people try to flip the sign because they got a negative answer. That's not what we do. However, with x being on the right, we don't like that. So flip them around, which means that's where you flip the sign to keep the arrow pointing at the negative 3. So with your number line, negative 3, there's your 0. We want a closed circle because it's greater than or equal to, and shading to the right. All right? Now, some fancy cases. Here's 4 more examples with a little bit of extra math involved. In this first one, what I have here, I'm going to have to move both an x and a number. I like moving the x's first, and you'll see why in a second. But if I subtract x from both sides, it gives me 3x minus 7 is bigger than 3. Now I can add 10 to both sides. 3x is bigger than 10. Divide both sides by 3. X is bigger than, or I'm sorry, less than 10 divided by 3. Now if I try to number line this guy, well, there's 0. 10 over 3, well, I can't do 10 divided by 3. I can do 9 divided by 3, which would be 3. 12 divided by 3, which would be 4. So it should be between numbers 3 and 4. So your point, actually your open circle, should be between 3 and 4 and shading to the left. Okay, number 2 down here. Well, we said when we have fractions, multiply, but I have 2 different numbers on the bottom. Well, let's multiply by the bigger number first. Let's multiply by 5. 5 times 2 divided by 5. Well, the 5's cancel out, leaves you just 2x. 5 divided by 3, I can't do it. I'll just leave it as that fraction, 5/3. And 5 times 3 divided by 5, 5's cancel out, gives you 3. Well, notice, I still have a fraction. So, let's multiply by the denominator again. Multiply by 3. 3 times 2x is 6x. Here the 3's cancel out and leave you just 5. And you get 9 left on that side. So now I can go and solve like normal. Subtract 5, gives you 6x is bigger than 4, which means when you divide by 6, x is bigger than 4/6, or 4/6 reduces to 2/3. And same thing, when you do your number line, there's 0, that would be 1. 2/3 would be somewhere in between, a little bit closer to 1. Open circle, shading to the right. Number 3 up here. What I'm going to do is the same idea. I want to distribute this through. I'm going to also distribute this negative through on that side. So 2x minus 6 on the left. I have x minus 8 and plus x on the right. I have x's together on the same side. I'll combine them into like terms. And here's why I like subtracting the x's first. When I subtract 2x from both sides here, well, what's going to happen is, well, they're going to go away. That's going to go away, this is going to go away. It leaves you with negative 6 is less than negative 8. Is negative 6 less than negative 8? No, it is not. This is a false statement. That means this is a no solution problem. No solution. So when I have my number line, I don't shade anything. The other option is what's going to happen when you get a true statement. So we'll show that here. I'll distribute through 4x plus 4 is less than 4x plus 6. Again, really easy to see when I subtract 4x from both sides. I'm going to be left with 4 is less than 6. Is that true? Yes, that definitely is a true statement. That means this is an infinite solutions problem. Some people might put the all reals or say all real numbers. What you do with this, if you have your number line, is you shade the entire number line. Because every single number, when you plug it in, is going to work with that equation. There you have it. Those are your inequality equations. Have fun.